Would you ask Dr. Lane to come back in, please? Thank you. Right, Dr. Lane, ready to carry on?
Yes.
Thank you. Yes, yes, Ms. Strange.
Yes, thank you. Yes, before we start, and just to assist the transcriber this afternoon, there were quite a few times where we were speaking over one another, and that makes it incredibly difficult for the transcriber to take a clear transcript. So I'm going to try really hard not to do that. It's my fault as well. But if you could also try to let me finish the question and complete your answer, and then hopefully we won't get into difficulty.
Apologies, I wasn't aware
it's fine.
that I was doing that.
Thank you. So just to pick up on that point about the size of the vent at the head of the stair, I just want to look at something with you. If we go to PSB's technical submission version 6, this is at PSB 50214.
Yeah.
And if we go to page 7 within this document, section 2.2 at the top.
Yeah.
It says natural air inlet ventilator as the title, and you can see in the text below, the stairwell has been provided with a penthouse louvre with a measured free area of 1 metre squared, and is permanently open to atmosphere. Now, is it likely that that's where you got your 1 metre square from?
Yeah, I just checked. So I went and looked at our site measurement appendix, so we didn't measure it. And it's the free area of 1 metre squared, and that's the number I've put into, I think we were talking about leakage calcs, weren't we? Yeah.
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 And that's a free area, so it's different to the...
Yeah.
Yeah, okay.
Now, given all of the complexities of the design that we've discussed, is it your opinion that those involved with the Grenfell Tower refurbishment, including Exova, Max Fordham and PSB, should have made sure that a CFD analysis, a computer fluid dynamics analysis of the proposed system was carried out?
The 3 parties, is that specific?
Well, I've said, do you think those involved with the Grenfell refurbishment, including Exova, Max Fordham and PSB?
Yeah.
I mean, if it's easier to answer those individually rather than as a group.
Yeah, no, because it's So I think, I suppose I'm more familiar with the concept of the fire engineer doing the CFD for a company like PSB, but I am also aware, obviously, of other companies who'll do the CFD themselves too, okay? And not the fire engineer. I will work on a job where I don't get to do the CFD. So I think, in my mind, particularly the fire engineer, and then should Max Fordham have insisted upon it? I think is that probably more contractual question rather than the truthful answer is someone should have done it, but in my mind the fire engineer and the mechanical engineer had a duty to make sure it was done.
Yes.
And I would expect PSB to have views on when a building is complicated or unusual or outside all the other CFD they've presumably done, that they might need to redo it for Grenfell Tower.
So to take PSB's position, if as was the case when they came into the project, no CFD analysis had been done, would you have expected PSB to have advised that such an analysis should be done?
I would expect them to advise it should be done, or that they would offer to do it themselves if they have that capability.
Yes. Now, when he gave oral evidence, Mr. Marnie indicated that the only reason this was not done was that there was no time to do it. That was at day 155, page 164, lines 19 to 21. Is that a good enough reason not to do a CFD analysis on a project? Because there's time pressures on the project and there's simply not time?
No.
Mr. Lay said yesterday that there was a prevalence of poor practice within the industry at the time in terms of doing these kind of computational fluid dynamics analyses, but he did accept that it fell below reasonable standards not to have done it. Do you agree with that?
Yes, I do.
Mr. Hansen's evidence was, in his first witness statement at page 10, was that in practice, CFD analysis is more suitable for new buildings where leakages in the structure can be checked and accommodated as the building is built. Is that right, in your opinion, that CFD is much more suitable for new buildings than existing legacy buildings?
Suitable, do you mean it's more, I don't know what you mean by suitable, so...
Well, let's look at his statement. At RBK 3033894, and it's page 10. This is Mr. Hansen's statement. If we look at paragraph 55, he says this: in practice, the computer modelling process, such as CFD, is more suitable for new buildings where the instance of leakages in the structure can be checked, accommodated as the building is built. The test in the guide, when carried out on site, only confirms the extract rate determined by the computer model. It does not take into account any leakages in the existing building structure. Now, do you agree with that?
Well, I'm really sorry, but the second sentence doesn't even make any sense to me. So I think I'll just, putting that aside, I think it might be easier to numerically model a new building, but I don't think I don't agree that it's more suitable, which I think is a different type of word. Is that okay?
Yes,
the test and the guide when carried out on site. I don't know what that means. Yeah.
Okay.
It takes into extract rate determined by the computer model. Yeah.
Now, in your earlier evidence to the inquiry during phase 1, you gave evidence about the risks of smoke being drawn out of the fire flat into the lobby due to the operation of the system. And you illustrated that in a diagram. If we could go to that, BLAS 5038, page 4. So that was a key diagram that you used to illustrate that point. Now, does that remain a concern of yours regarding the system as designed at Grenfell Tower?
Well, any system can pull smoke out of, any mechanical system can. Yeah.
So is that a known risk with any form of mechanical system?
Yes.
And is this addressed by any such smoke simply being vented up the extract shafts? Wouldn't that deal with any ingress of smoke that's been sucked from the fire flat?
Sorry, are you asking me that in the system designed to apparently not extract smoke, if it will extract smoke when it flows out from one of the flats?
I think that's the point that's being made, is that even if that's a risk, isn't that going to be addressed in practice, because you'd have some smoke extraction from both the north and south shafts?
Well, it depends on the quantum of the smoke and the quantum of the so-called extract.
Right. And is it possible to do any kind of qualitative or quantitative assessment of this risk at this stage?
Is it possible what?
Well, let me put it a different way. When Mr. Lay gave evidence yesterday, he said, yes, that's a theoretical possibility, but it's theoretical only, and it's not a possibility that one would expect a designer to take into account in this kind of system. Do you agree with that?
He's saying that smoke does leak out of the flat, or it's only a theoretical possibility it would leak out of the flat? Sorry?
I think he's saying the latter.
So it's only theoretically possible smoke leaks out of a flat with the door closed? Are we talking about the door being closed or open?
I think he's saying it's only...
Or both?
Sorry.
Oh, sorry. Yeah.
I think he's saying it's only a theoretical possibility that this type of system is going to be positively pulling smoke from the fire flat into the lobby, and he wouldn't expect a system designer to take that into account. That was his evidence.
Yeah.
Do you agree with that?
I don't think so.
And is a CFD analysis one way in which you could assess whether that risk was one which was concerning or not on a particular project?
Yeah, that's my understanding.
And in your supplemental report, you raise a particular concern about the way the system was designed, such that it might mean that if a flat door was open and the stair door was shut, the system might carry on operating at high level because the pressure difference between the stair and the lobby would have been lost due to the open flat door as opposed to the open stair door.
Yeah.
And you say that that could lead to a phenomenon of smoke being sucked from the flat into the lobby. Now, have we understood that right, that that's the concern?
Yeah, because the fans never turn off. They go to high as the if you want to say, the pressure is stabilising between the stair and the lobby.
Yes.
Okay?
Yes.
Yeah, and then some additional smoke might be expected to be drawn out on top of any other smoke already leaving the flat of its own.
Yes.
Buoyancy, etc.
Yes, because...
But the fans remain on high. That was something that seemed to kind of get a bit lost, I think, when it was being talked about during the summer. Yeah.
Yes, and the concern, I think, is that the system doesn't know whether there's been a loss of pressure because the stair door's open or because the flat door's open, does it? It's not sensitive in that way.
No, because it's just so if you, I suppose another way of looking at it is if you open the flat door and if there's leakage, available, it's almost like the lobby is extended in the context of the two little pipes between the stair and the lobby. It's no more intelligent than that.
Yeah.
So that it's only taking samples from the stair and at the lobby. It's no cleverer than that. The system. Anyway. Yeah.
And do you consider that is something that should have been expressly considered by PSB at the time it did its design?
Expressly considered. Well, they should know about it. Yes.
And should that be documented, that they've looked at that risk and evaluated that risk? Would you expect that to be dealt with somewhere in the design documentation? Is that what you're saying?
Oh, I see what you mean. Sorry. So the thing about the handy thing about numerically modelling all these scenarios is you then understand the behaviour of the smoke in those scenarios, and by definition then it's documented. You'll have reviewed it and you'll have satisfied yourself it's appropriate. Yeah. Yes.
So it's another reason why you need to numerically model all these systems.
Yeah, it's something that the model allows you to understand and interrogate.
Yeah. And just finally on this point, is it right that, in your opinion, mechanical calculations for pressure drop ought also to have been carried out when PSB was selecting the fan sizes for the new system?
Yes, yeah.
And are you saying that the narrow size of the existing shafts might have caused increased pressure drop in the shafts, making it important that the fan sizes were carefully selected to accommodate that?
Amongst lots of other things. I mean, normally there's a spreadsheet of all the different items that contribute to pressure drop as an aggregate of different things. It's not one. It kind of sounds like it's one thing. It's an aggregate of all different things. So the size of the shafts is relevant to the calculation.
And which professionals would you expect to be involved in that exercise in making sure that the fan size was correct, given the pressure drop to be anticipated? Is that something for the system designer, the detailed design, or is that something you expect a fire engineer to get involved in?
No, I think I would absolutely be calling the mechanical engineer when it came to that level of detail.
Yes. And just overall, in terms of your conclusions about the system design, you say, if we can go to your supplemental report, BLARP 2 5043 at page 36, you say at 3.1.27 at the bottom of that page, you say, notwithstanding this demonstration of options available to the design team at the time, I remain of the view the fundamental issue is not the system type PSB chose, it's the quality of the mechanical extract depressurisation system they designed. PSB failed to provide a smoke ventilation system which complied with the functional requirements of the building regulations. Now, does that remain your view?
Yes.
And has anything that Mr. Lay has said in his evidence yesterday changed your view in any way?
No, but there's lots of things we haven't spoken about yet. It's not just about where the smoke was flowing. So I prefer to say that at the end.
Okay.
Yeah.
Fine. I'm going to move on then to dampers
Yeah.
and compartmentation. And I want to go within this supplemental report to page 105. And I want to look at 6.1.1 and following. So you say there are 7 published standards under the framework for the testing and classification of dampers and ventilators. These range from products called natural smoke and heat exhaust ventilators, which require the lowest performance in the event of a fire, as they have a very simple functions to open or remain open to ventilate smoke directly from a space, right up to smoke-controlled dampers, which rely on the most complex actions and are to provide the highest protection standards in the event of a fire, because they actively direct smoke along a specified route which can then be altered over the course of the fire. This range of performance, clearly defined in the published standards, must be kept in mind when reading this section of my supplemental report. And you go on, you say, Mr. Jones Gilbert stated in his oral evidence of the inquiry that the Gilbert Series 54 damper is a smoke evacuation damper, which he admits is an industry-defined term to which there is no reference made in Approved Document B or any British standard. As stated in their evidence, PSB considered that the Gilbert's damper met the technical specification of section 8.2.5 of the SCA Guide 2012, such that the Gilbert's damper was an automatic opening vent smoke control damper used for ventilation from corridor or lobby into the smoke shaft or smoke controlled duct. And you say the emphasis is yours in terms of they've said that it was a form of smoke control damper. And you say at 6.1.6, Mr. Jones' description of the operation of a smoke evacuation damper is consistent with that of a natural heat and smoke exhaust ventilator, which, as I explained below, is the lowest performance possible in terms of functionality. But he also refers to the damper having passed the BSEN 1366 Part 2 test requirements and hence having met the requirements in the SCA Guide for an automatic opening shaft ventilator, which is uniquely defined in section 8215 of the SCA Guide. And then at paragraph, if we go within your Module 3 report to BLARP 2, 5036 at page 26. Sorry, I think that might be a wrong reference. Don't worry. So you've said in your Module 3 report, I'll just read it out as a short quote, that no damper purchased and installed as part of the primary refurbishment lobby smoke control system had been fire tested or classified in accordance with the requirements of the Approved Document B. Is that correct?
Yes.
And does that remain your view?
Yes.
And is it also your view that the dampers that were installed meant that the system could not satisfy the functional requirements of the building regulations? That's B1, B3 and B5.
Yes.
Now, I want to ask you some more questions about the need for the S certification for these dampers. And in your supplemental report, you identify an area of disagreement with Mr. Lay about whether or not the approved document permits a damper with an integrity-only test, an E-only test, to be used on escape routes. Now, if we can go within approved document B to CLG 50224 at page 61. This is under the general provisions heading. And if we look at 5.48 at the top right-hand column, we can see it says there, ducts passing through the enclosure of a protected escape route should be fire resisting, i.e. the ductwork should be constructed in accordance with method 2 or method 3. And then there's a note underneath that, and it says, note, fire dampers activated only by fusible links are not suitable for protecting escape routes. However, an ES classified fire and smoke damper, which is activated by a suitable fire detection system, may be used. Do you see that?
Yeah.
Now, can you just explain what a fusible link is? Is that the same as a thermal link?
Oh, I think so, yeah. So at a certain temperature, it causes the damper to snap shut.
Yes.
I've never thought, yeah.
And what's your understanding of what this guidance is saying about whether an ES classified damper should be used to protect an escape route? So we can see it says in the final part of the note, however, an ES classified fire and smoke damper, which is activated by a suitable fire detection system, may be used.
Yeah, that is my understanding.
And but isn't this potentially silent about whether a damper which has just satisfied the E classification but isn't activated only by a fusible link is appropriate on an escape route?
So isn't it silent? Okay, so the first sentence is a fire damper, and a fire damper has its own definition, and by definition it doesn't have S. And when it's tested, you have to test the fusible link. And then the second sentence, so to me that's a general recommendation. And then the second sentence, the author of this, unusually worded two sentences, says an ES classified, and therefore in the ADB it's called a fire and smoke damper, so it's the same thing, activated by suitable fire detection system may be used. And my understanding of that is it's doing two things. It's explaining, first of all, that the S rating, that higher, the higher performance is needed, and they need to be able to close quickly rather than wait. A fusible link it can take some time to close because it depends when the temperature hits it. When a damper is activated off a fire detection system, the concept is it's closing very quickly in the fire area.
Yes.
So that's how I read those two.
I see.
Together.
Can we agree, though, it doesn't say an ES classified fire and smoke damper activated by suitable fire detection must be used? It says may be used.
I'm not aware the ADB uses the word must anywhere.
I see.
Yeah.
I see. And is it right that you would read this together with other appropriate guidance, including BS 9991 2011, which also contains some guidance about dampers on escape routes?
Sorry, can you repeat the question?
Is it right that you would, as a designer or reviewing these systems, you'd look at the approved document, but you'd also have a look at what BS 9991 said about dampers on escape routes?
You could do, yes. Yeah.
If we go to BS 9991, before we do that, do you think it's logical that dampers on escape routes need to have the S smoke leakage requirement as well as an E integrity requirement in order to satisfy the functional requirements of the building regulation?
In a high-rise residential building with no sprinklers and a stay-put policy, yes.
Right. So I think what you're saying is anybody reading this also has got to bear in mind what the functional requirements are that you're trying to meet ultimately.
Like every single other thing you do, not just what's written in the approved document B.
Yes.
Yeah.
And would you consider a damper that didn't have the S classification to be capable in a building like Grenfell Tower of satisfying the functional requirements if it only had an integrity and not a smoke leakage requirement.
I don't think that, no.
Now, if we go to BS 9991 2011, it's at BSI 50621. So this is a publication from 2011, Fire Safety in the Design, Management and Use of Residential Buildings Code of Practice. And if we go to page 117 of this, we can see at 39 at the bottom of that page a heading HVAC systems serving the whole building or interconnecting dwellings and other residential units. Do you see that?
Mm-hmm.
And can
Yes.
you just remind us what HVAC stands for?
Heating, ventilation and hopefully air conditioning systems.
Yeah. And it says there immediately under the title, mechanical HVAC systems serving the whole building should be designed to prevent the spread of fire and smoke from the room of fire origin throughout the building. In particular, measures should be taken to ensure that air movement in the system prevents incursion of fire and combustion products into protected escape routes or allows lines of fire compartmentation to be breached. And then if we go over the page, at the top of page 118, it says measures to aid firefighting control should be incorporated, including the following. And then I want to look at D. It says there, where a ductwork system serves more than one part of a compartmented or fire-separated escape route, smoke detector-operated fire dampers should be provided where the ductwork enters each fire-separated or smoke-separated section of the escape route. And then it goes on, where a fire damper is used to protect an escape route, it should be tested in accordance with BSEN 1366 Part 2 and an ES classification equal to or greater than 60 minutes in accordance with BSEN 13501 Part 3.
Yeah.
Do you see that?
Yes.
Now, what does this part of BS 9991 mean for the dampers at Grenfell Tower, in your view? Is this a relevant paragraph describing the situation at Grenfell Tower, that we have fire dampers used to protect an escape route?
Yes.
So is this guidance that you would expect a reasonably competent designer of a system to take into account in terms of whether or not an ES classification of damper ought to be selected?
Yeah. So first of all, I would expect the fire strategy to very clearly set the standard for the dampers in the lobby, absolute first priority. And then in an ideal world, you know, the system designer, so PSB, can read that and understand that that's what's required of them in this particular building. Okay, that's the first thing. And then I think, because if, and then to be capable of understanding the differences in the different types of damper available on the market when making their decisions about what they're going to do in a particular building. Yeah. But it's a life safety system in itself, you might say, actually a really important part of compartmentation. We've talked about that at length to do with Grenfell Tower and the stay put policy and how high-rise residential buildings, you know, in England are, you know, dealt with, and the, you know, the so-called no plan B. So it's such an important part of a fire strategy to make that clear. And I see the primary responsibility there, to be clear. Okay?
Right.
But obviously there's a reasonable expectation that PSB or any other company like them would understand the different types of damper and when they're appropriate for use.
I see. So I think you're saying the primary responsibility is on the fire engineer to specify the type of damper.
Yeah.
But you'd also expect a designer of a smoke control system to be aware of the different types of damper and to select appropriately according to its use in a building.
Yeah, the building in question or the particular hazard in the building in question. Yeah.
Yes, thank you. Can we just look at another part of this BS 9991? If we go to page 73 in this document, there's a section headed Mechanical Smoke Ventilation Systems.
Yeah.
And it says there, where a mechanical smoke ventilation system uses a shaft,
Yeah.
it should conform to, and then it's got various paragraphs that it has to conform to, including 26.2.4.2G is one of them. And then if we go to page 72, where we see G, it's there towards the bottom of the page, third paragraph from the bottom. It says here, the lobby or corridor vents in the closed position should have a minimum fire and smoke resistance performance of 30 minutes and a leakage rate no greater than 200 cubic metres per hour per metre squared when tested in accordance with BSEN 13662. Now, this appears to set out a performance standard for a damper which has some similarities to an ES-type damper, including maximum smoke leakage rate, but it has only a 30-minute rating and doesn't appear to require an ES damper to be provided. Now, do you consider that that part of the British standard was relevant to the dampers installed at Grenfell Tower?
I don't agree that G says an ES damper. So when I read that, that is an ES damper,
I see.
just to be clear. Okay.
I see. So you interpret that as saying we do need an ES damper.
I don't believe I'm interpreting. That's what I read.
I see.
Okay.
I understand.
Yeah.
Is another relevant factor potentially that the earlier section we were reading was expressly concerned with protecting escape routes, whereas this is not saying anything about escape routes, it's just talking about mechanical smoke ventilation systems.
Okay, so both sections have the same leakage standard, the 200. And then I think where you might be trying to get to, please correct me if I'm wrong, is then the fire resistance is different.
I think that
Is
might
that
be
what you
what's
meant?
being suggested.
Yeah, okay. And so the leakage is relevant to an escape route, and in picking the compartmentation needs on your escape route, you have to understand the particular building you're in and what the overall rating is, etc. I hope I haven't...
No.
Yeah, okay.
Now, taking those two pieces of guidance together, do you consider that there's any ambiguity as to whether a damper protecting an escape route needs to be S rated in a building like Grenfell Tower?
I don't think there's ambiguity.
And would you expect a reasonably competent smoke control designer and a reasonably competent fire engineer to be aware of this requirement for the damper protecting an escape route to be S rated?
Yes.
And can you just help? It sounds maybe an obvious question, but I'm going to put it. Is the distinction in functional performance between an E only and an ES damper important to the health and safety of people in a high-rise residential building?
It's particularly important to the health and safety of people in a high-rise residential building, for the occupants and for the firefighters.
Yeah. Now, in terms of the type of damper which should have been specified, in your supplemental report, you referred to Mr. Jones's description, he's from Gilbert's, his description of the Series 54 damper that they supplied. And he stated in his oral evidence that the Gilbert's damper was a smoke evacuation damper, which he said was an industry-defined term to which there's no reference in either approved document B or any of the British standards. Have you ever come across the phrase smoke evacuation dampers before as used by Mr. Jones of Gilbert's?
Yeah, I think I have, and all sorts of other combinations as well, which I would struggle to list out sitting here today. But it's common that there are different phrases used to describe those objects.
Yes. Now, relative to the recognised and certified classifications of dampers, such as a smoke control damper, a fire and smoke damper, or fire dampers, where does the performance of smoke evacuation dampers, as tested by Gilbert's, fall on the spectrum?
Sorry. Did you say fire damper, fire and smoke damper, and smoke control
Yeah.
damper? So the Gilbert damper falls underneath the three.
So it doesn't even satisfy the definition of a fire damper, never mind a fire and smoke damper or a smoke control damper. Is that your evidence?
That's as I've set it out in my report.
Yeah. Now, if we go to your Module 3 report at BLARP 2, 5035, and look at page 95, you say at paragraph 4.8.81, you say in relation to the dampers at Grenfell Tower, all of these dampers were required to be smoke control dampers as they all needed to function in either the open or closed position, depending on the operation mode of the smoke control system. Now, Mr. Lay yesterday in his oral evidence queried whether the dampers did in fact need to be able to open and close in the event of a fire at Grenfell Tower, because he wasn't clear on what the purpose of the fireman's override switches was. And what he said was, it might be that the intention of those was for the fire brigade to use them in a fire by changing the floor of operation of the smoke control system during a fire event. But he also said it's possible that the fire brigade might simply use those override switches for smoke clearance after there's been a fire which has been dealt with. And therefore he questioned whether in fact these dampers needed to open and close during a fire rather than just simply close and stay closed. Now, what's your response to that?
My response to that is the system as described and offered to the brigade was they could take control of the smoke control system, and sometimes I just don't know how to answer these questions, I have to say. They might like to do that during the fire, they might like to do that after the fire, and so the dampers need to be able to open and close in any of those conditions.
Right.
Yeah.
And where do you get that understanding from? What's that based upon?
When you read what a smoke control damper is in part, quickly, 8 or 10. Yeah.
Yes, but in terms of the Grenfell system, how did you come to understand that the purpose of those yellow key switch boxes was that you could use them during a fire or after a fire?
Because I certainly didn't read they have been designed to only work in cold temperature conditions anywhere. That might be the easiest answer to give.
If that
Sorry. Yeah.
If that had been the intention of those dampers for use by the fire service, that they were only to be used for smoke clearance purposes once the fire was out, would you have expected that to have been clearly communicated in the instructions to the system?
Yes.
That we saw at ground floor level?
Absolutely.
Now, is it right that ADB itself doesn't refer to or state any recommendations about smoke control dampers, the highest performance of damper?
Yeah, that's correct, as I've explained at length in my report.
Yeah. Now, if we go, however, to the relevant British standard which deals with smoke control dampers, this is at BSI 401777. This is BSEN 1366 Part 10, 2011, and the date's important, from 2011. And it's headed Fire Resistance Tests for Service Installations, Part 10, Smoke Control Dampers. And we can see on page 12 of this standard that there's a definition of smoke control dampers that are given. Do you see that at 3.27? And it says it's a device automatically or manually activated which can be open or closed in its operational position to control the flow of smoke and hot gases into, from, or within a duct. And if we go to the introduction to this standard, which is on page 8, we get some more context on the use of smoke control dampers. And I just want to read those first two paragraphs under the introduction. It says this: when smoke and heat exhaust ventilation are being considered, it becomes apparent that a clear path needs to be made between the area where heat and smoke is being generated, the fire, and the outside of the building. To create this path, there needs to be ducts, and the smoke extract path needs to remain uninterrupted. This means that smoke-controlled dampers at the fire and along the path have to be open and remain open. Smoke-controlled dampers at branches or on the surface of the duct along the path need to be closed and remain closed. In fact, if the duct crosses a compartment boundary, it becomes part of the fire compartment in which the fire started. And then the purpose of this European standard is to define test methods to evaluate the abilities of smoke-controlled dampers too. And then we can see, for example, at little 3, it says change state from closed to open at elevated temperatures and vice versa. Yes?
Yes.
So that's some useful context to these smoke-controlled dampers in that British standard. And you have said in your report, I don't think we need to turn it up, it's BLARP 25035 at page 90, paragraph 4.8.48, that the primary functional difference when comparing a smoke-controlled damper with the other two types, that's fire dampers and fire and smoke dampers, is that a smoke-controlled damper must be capable of opening and closing in the event of a fire. Is that right?
Yes.
Based on what you know of other types of dampers or ventilators, are there any other types that are also intended to perform that function?
I don't understand the question.
So would there be any other type of dampers that would be able to give you that functionality to be able to be capable of opening and closing and vice versa in the event of a fire? There's not any other category, is there?
Well, not that I'm aware of, but I don't know if it's a kind of a, yeah.
Okay.
No.
Now, we know that PSB and Mr. Lay have drawn attention to certain recommendations in the SCA guide about smoke-controlled dampers.
Yeah.
And if we can turn up the 2012 SCA guide, it's at LFB 59241. This is the 2012 version of that SCA guide. And if we go to page 36, so, and under 8.2.5, it says there, no formal product standard exists for the use of these products in this application. To ensure the necessary product performance is achieved, it's recommended that the AOV should be regarded as a smoke-controlled damper and the relevant product standard should be considered. Do you see that?
Mm-hmm.
Now, is it right that in 2012, when the SCA guide was produced, that there was no formal product standard for these dampers, smoke-controlled dampers?
I put the date in when it was produced in my report. I just can't remember it right now. I don't have any of my reports with me.
But I think what you tell us is that the 2011 British standard that we just looked at was published just before this. Is that right?
Yes. So are you? I'm just prefer because I don't have my reports. I can't recall all of these things. So
I understand.
It was my understanding is by the time this was published and in circulation, from memory, the standards had been published by then. Just when it was being drafted, they were not.
Yes.
Yeah.
And what the SCA guide does, if we go over the page at page 37, is it says in the second line down that there are several applicable smoke-controlled damper standards, and these are listed below.
Yeah.
And indeed, we get EN 1366 Part 10, which is the smoke control damper standard there, listed, which is the one, it's actually dated 2011. It doesn't say the date there, the one that we just looked at. So it gives those standards.
Yes.
But then it goes on to suggest some alternatives. And what it says is this, below those standards, it says, any damper tested as fire resisting tests are made using the standard time temperature curves, supported by an ad hoc operation test at elevated temperature, e.g. 300 degrees and or 600 degrees C for 1 hour, etc., using a drive open, drive close actuator could also be acceptable. These test standards are listed below, and it lists some other test standards. And then it goes on and it says in the final line, dampers tested in the closed position to BS 476 part 20 could also be suitable. Do you see that?
Yes.
Now, to what extent, in your opinion, do these recommendations address the need for a damper on an escape route to limit smoke leakage as required by BS 9991, for example?
As in order to meet the functional requirements in a high-rise residential building, you mean?
Yes.
Reading these 3 sentences as written, you can't see any signal that smoke leakage is relevant.
And to what extent do these recommendations address the need for a damper installed in a dual environmental and smoke control system to perform properly after multiple, perhaps thousands of open-closed cycles? Is there anything in there that's addressing that?
No.
Now, picking up on that last sentence of that guide, that dampers tested in the closed position to BS 47620 could also be suitable, can we just look at ADB again? It's CLG 50224, page 88.
Yeah.
So I want to look at paragraph 10.15, and it's note 1 that I want to look at. It says there, fire dampers tested using ad hoc procedures based on BS 476 may only be appropriate for fan-off situations. In all cases, fire dampers should be installed as tested. Now, in your opinion, is that relevant to whether or not ad hoc testing to BS 476 can be appropriate in a system like Grenfell Tower?
So there's a warning here, and it's not replicated in the SCA guide. Maybe a good way to explain that.
Is it right that BS 476 Part 20 is a historical test standard from 1987 relating to testing fire resistance of elements of construction rather than dampers specifically, and it had been superseded many years before that SCA guide came out?
I'm being really, I'm going to say yes. BS 476 actually on its own doesn't mean anything, but anyway, but yes, I know what you're trying to ask me. Yeah.
Well, it was, so in the SCA guide, it was BS 476 Part 20 that was being cited.
Yeah.
Is that what I'm saying is that a pretty out-of-date standard to be referencing in the SCA guide?
Well, Part 20, she said, frantically trying to remember. I think that's where this, 21. It's just a description. It's not a test for a damper, for example.
Yeah.
It's not a damper test standard, let's put it that way.
Does that contain any smoke leakage measurements?
No.
We can't see that it does.
No. No, it wouldn't do. Yeah.
And what is your view about the appropriateness of the SCA guide recommending or permitting the use of a damper tested to that standard, BS 476 Part 20, as a potential route for a smoke control damper?
I think it's not appropriate.
Now, by making recommendations about the appropriate use of dampers without reference to the S maximum smoke leakage requirement, did the 2012 and 2015 versions of the SCA guide, in your opinion, reflect the functional requirements in the building regulations, including B1 and B5?
Not for high-rise residential buildings, no.
If a designer was designing a system of a type that was referred to in the SCA guide, would it be reasonable simply to use that guidance on the specification of such components?
My opinion on any industry guidance, not just the SCA guidance, is it has to be read in the round. So that means understanding other, say, statutory guidance documents and non-statutory guidance documents, and that you need that level, I suppose I'm going to have to say knowledge and competency, before you interpret an industry set standard. And I don't have that view solely about the SEA guide. I just want to be fair about that. I think it applies to any industry guidance document. Okay.
Yes. So is it your evidence that a reasonably competent designer specifying components for a system wouldn't just take the SCA guide at face value, but would ask the question, is this going to meet the functional requirements in the building that I'm designing for?
I think you have a duty to do that under both, well, anyway, I don't know if you need me to say it. I think you have a duty to do that under both CDM and the building regulations myself.
Yeah.
Yeah.
Now, following on from Mr. Lay's evidence yesterday, it appears to be agreed that the Gilbert's dampers didn't even meet those lower SCA guide recommendations, because the testing method which had been done was from the closed position and was not compliant with BSEN 1366 Part 2. And as Mr. Jones in his evidence made clear, the dampers were also not fire and smoke or smoke control dampers. Now, in your view, was that something which a reasonably competent designer in receipt of the test data from Gilbert's could have been expected to identify and pick up?
I think that the Gilbert's information they sent to the design team at the time informed the design team. I can't remember the words off by heart, but it did tell them the damper. Do you want to put it up? Because I can't.
I haven't got the reference here.
So just to paraphrase the detail in my report, which is more important than this paraphrasing I'm going to do now. There was a warning in the document that it hadn't been tested to the required standard, okay? But I suppose, having done what I've had to do in the last 2 years to try and decipher this problem, I think I probably have some sympathy that it's quite a difficult thing to derive all on your own on a job. I have found it incredibly difficult when doing it for the inquiry. Okay.
Yeah.
But in this particular case, there was some warning. Okay. But then you needed to get into the detail of the test and what that meant and what you were trying to do. Okay.
Yeah.
Okay, sorry, Ms. Grange. I think that anyone who's taking responsibility for a product, as we've spoken about again at length for the last few years about the cladding, everything else, dampers are not different. The designer has to be able to understand the background testing and its relevance to the application. The designer is solely responsible for placing that product in. It's the same for cladding as it is for dampers.
Okay, so just to be absolutely clear, are you critical of PSB for not picking up that the damper hadn't been tested in full compliance with BSEN 1366 Part 2 or not?
Oh, well, I am of PSB, yes, because they are a member of the Smoke Control Association, or certain individuals there were, and they understand the SCA guide very well, and I trust, therefore, they understood how to interrogate the damper standards.
And would you have expected them to then communicate that these dampers didn't have any classification or formal certified status to others on the refurbishment project? Should that have been communicated to others?
Yes, it should.
And who are the others that it should have been communicated to?
So I think building control needed to know. The fire service will have wanted to know. And then the responsible person needed to know. I should say again, though, if the proper performance needed for Grenfell Tower had been written down in the first place, and people were assessing products off those standards, that might also have helped. Okay?
Yes, I see. So I think what you're saying is, had the fire strategy contained the performance standards for the dampers, and people were then referring back to that and checking whether that standard was met, that would have helped everybody.
Yeah, exactly. Because on most good jobs, the contractor in the end will kind of go through a list of, they said this, have I got that, have I checked my test certificates. So if it isn't written down, you run the risk of more error. But in this particular case, there was no performance set by anyone, and despite Gilbert's communicating it wasn't a certified damper, it was accepted willingly.
Now, can we look back to your supplemental report, BLARP 25043 at page 128? And at section 6.7, you've got a heading, Development and Revision of Damper Guidance in the SCA Guide.
Yeah.
And I just want to read out the 2 paragraphs setting out the purpose of this section. So what you've said at 672 is, as I've set out in section 6.6, when compared with the provisions in ADB, the SCA Guide 2012 and 2015 introduced a set of unique and substantially lower performance standards for dampers in smoke shaft systems. And you go on at 673, the purpose of this section is to show evidence of how the alternative standards were originally developed for the SCA Guide 2010 as a stopgap measure, but were instead retained until their removal from the SCA Guide 2020 after the Grenfell Tower fire. Now, without going through all the emails that you quote in this section of your report, is it a fair summary of your view to say that the SCA Guide's alternative options for appropriate dampers appeared from these emails to be originally intended as a temporary course of action pending the publication of standards for smoke control dampers, which we saw was done in 2011?
Yes.
And is it right that even though we then had a standard published in 2011 for formal smoke control dampers, the alternative routes in the SCA Guide were not removed after the standards publication? And you say that that was a substantial, or if people followed that guidance, there was then a substantial reduction in performance requirements in the SCA Guide, which was out of line with other guidance, including British Standard guidance. Is that correct?
Yes.
Thank you. Now, Mr. Lay, in his evidence, in his report and his evidence yesterday, he acknowledged that the Gilbert's dampers weren't certified to certain formal standards, nor did they meet the SCA Guide recommendations, as they were contingent on a compliant test from an open position. If we can go to page 199 in Mr. Lay's report, LAY 701 at page 199. He deals with certification at 663. And he says this: based on the information in the WF 309850 report, so that's the test report that was obtained for the damper may be able to achieve an E60 classification, so that's an integrity 60 classification. However, it cannot do so on the basis of the report itself, as the test was not conducted fully in accordance with the procedure of BS EN 1366 Part 2, in that the damper was closed at the start of the test. It is credible that, based on the information in that report, the damper could have been classified as a 60-minute fire damper using BS 476 Part 20 methodology, but I have not seen a classification of the damper to this standard. And if we can also go to page 203 of his report and paragraph 678, he says at the top, after considering the dampers, he said, based on the above, I consider that the dampers had performance characteristics that could allow them to perform adequately within the system, despite the issues with certification. Now, in your view, is it open to a reasonably competent designer to specify a component which has not actually been tested in respect of particular performance characteristics, but which is believed could or may pass that test if done?
No.
So is such hypothetical testing ever an acceptable substitute to actual testing?
What's a hypothetical test? Sorry.
Well, saying to yourself, we haven't done the test in the way that it sets out, but knowing what I know about this damper, I think it might well pass that test.
It'll
and
be kind of grand. Hopefully it'll be grand, I think. So when I think about these dampers, I actually find Mr. Jones's evidence the most important. And he explained why what on the surface might appear like a minor point, the damper needs to go from the closed to the open position. He explained really carefully, and I listened to him very carefully, about why that's a very difficult motion in heat for something made of metal to go through. And I interpreted from what he said, you probably have to make your damper a little bit more robust in all sorts of different little ways. I couldn't possibly speculate. And so I think that's why this test and doing the test is so important. So you can see its behaviour in a standardised way and compare the products side by side as a designer. So I'm not into hypothetical testing or hoping an untested product might be grand. I consider that very unprofessional, actually.
Now, some questions about cumulative versus a constant leakage rate. If we go to your Module 3 report, it's at BLARP 25035 at page 228.
Yeah.
You included a graph of the volume flow rate during the test of the Gilbert's damper. And if we just look at this graph, I'm going to read out what you say about the leakage on the preceding pages. What you say is it's interesting to note that as a result of dropping below the smoke leakage limit of 200 cubic metres per metre squared per hour from 9 minutes to 53 minutes, the cumulative leakage of this damper was in fact lower than that of a damper with a constant leakage of 200 cubic metres per metre squared per hour, which would have complied with ADB 2013. Now, Mr. Lay has referred to this observation in his report when considering how leaky the Gilbert's dampers were. Now, are you able to help us as to why the maximum leakage requirements in the relevant standards are not expressed as a cumulative rather than a constant figure? So why they require you to stay under the 200 figure at all given points in the test, rather than being expressed as a cumulative average across the test period?
Yeah. So first of all, I put this graph in my report. I think it's important you understand why, because my original plan when I started out on this journey was I was going to try and quantify leakage, because I was asked to look at leakage to see if it was a concern the night of the fire. And I was going to try and quantify the leakage, and in the end I wasn't able to do that satisfactorily, and this graph has remained. It doesn't say anywhere, as I'm aware, as to why it isn't, an aggregate or cumulative quantum, and instead it's in the moment. But I can only guess it's because the damper has to perform in the moment on the night of the fire. But that is a guess because it's not written down. And then I think you asked me something else as well.
No, that's fine.
Yeah.
Taking a step back and thinking about a real-world application and bearing in mind life safety, when assessing whether an escape route is safe for a resident to go through during a given minute, is the instant leakage rate more important than an average rate over a much longer time period?
Oh, yeah, I see what you mean. So first of all, remember, this isn't the damper that was installed in Grenfell Tower. This is the Gilbert damper that was tested, okay? So the damper in Grenfell Tower was smaller, and the leakage standards say the smaller the damper, the higher the leakage in the same test. So this isn't representative. This was the problem I had in the end. It's not actually representative of the installation in Grenfell. Why is damper in the moment? Sorry, can you just say the question again rather than cumulative? On the night of the fire, I would imagine it's both.
Right. What I was asking is does the standard require it to be the instant leakage rate? Because a resident could be escaping at any point along this time curve, and to the residents, from the resident's perspective, it's not really relevant whether there's an average that's underneath. What's relevant is whether they're getting an unhealthy dose of smoke as they're escaping. Is that the reason why it's an instant leakage rate?
Yeah, so I don't know that for a fact, so I prefer not to speculate, if you don't mind. I just, I don't know, and I haven't thought about it, in that context.
Okay.
Is that okay? So I prefer, I don't know the answer to that.
Okay.
Yeah.
Now, when addressing the cumulative leakage issue, if we could go to your supplemental report, BLARP 2 5043, I want to look at page 140, where you've got figure 6.4. This is a figure that I took Mr. Lay to yesterday. And if we blow that up, figure 6.5, it's the BSEN 1366 Part 10 2011. So that's the standard that dealt with smoke control dampers. And you are trying to explain the test conditions for this smoke control damper in this figure. Is that correct?
Yeah, well, it was because I was fascinated by what Mr. Jones said, and I was trying to work out how I could understand that using characteristics of metal under heat.
Yes. And in box B, you've drawn attention to certain properties that the metal would have under heating, including expansion and loss of strength and stiffness. Is that correct?
Yeah.
And Mr. Jones of Gilbert's, he said during his evidence, this is day 157, page 73, lines 17 to 23, he said it would have been more onerous to start it from the open position because of expansion of materials. If the damper was open for a period of time, then what would happen is the damper blade could swell, the frame could swell, etc. And then we'd have to watch out for more adjustments, if you will, of the damper product itself.
Yeah.
So based on what you know about the properties of the metal, does that sound right, that it's likely to be much more onerous to start the damper from the open position, heat it, and then see whether it can close and what the leakage requirement is, than if you've started only in the closed position?
Yeah, exactly. And then presumably when you've done enough tests, you're able to work out then the kind of strengthening or other things you need to do so that the final product, can get through the standard test. I actually found that really interesting. Anyway.
Yes.
Yeah.
But is it right that without actually carrying out the test, it's not going to be possible to say what the difference might have been for any particular damper?
Exactly. Yeah.
Now, the size of damper which was tested by Gilbert's was different. It exceeded the size of damper that was installed at Grenfell Tower. Is that right?
Yes.
And does that mean then that comparing the cumulative leakage of the Gilbert's damper to that of the damper installed at Grenfell Tower is not going to be comparing like with like?
That's correct, and that's why I had to give up in the end, and I decided to quantify the whole thing.
Now, in terms of durability of operational reliability of the Gilbert's dampers, I just want to look at that aspect of damper performance.
Yeah.
If we go within your Module 3 report to BLARP 25035 at page 92, and if you look at paragraph 4.8.70 at the bottom, you tell us what the key differences are for the test method for evaluating integrity and smoke leakage performance for smoke control dampers. And you say the key differences are as follows. And if we go over the page, The first difference is that the smoke control damper is subjected to a greater number of open-closed cycles prior to testing. This is termed the durability of operational reliability. A smoke control damper intended for a combined smoke and environmental system is subjected to 10,200 open-closed cycles prior to fire testing. A fire damper and fire and smoke damper is subject to just 50 open-closed cycles. And then you also point out in B, the point we were just discussing, that the ability of a smoke control damper to change from open to closed or vice versa at elevated temperatures is tested in that particular more onerous standard. Now, as for the open and closed cycles requirement, as the dampers were part of an environmental ventilation system at Grenfell Tower, is it right that they were reasonably expected to open and close many times each week?
Each week, yes, they were programmed to cycle open and closed all day, as a function of temperature. Yeah.
And no such testing to anything like 10,000 cycles occurred for the Gilbert's dampers, did it?
Not that I'm aware of.
Absent testing data on their durability following long-term use, is there any available evidence about how they might have performed in a fire scenario after many months of use in an environmental system? Is that something that could just be assessed in general?
I don't think. I don't know. I don't know.
Mr. Lay yesterday, his response to that point was, well, you could expect your maintenance of the system to pick that up. So if they're having problems because their durability simply isn't good enough, then you would expect your regular maintenance visits to pick that up. Is that, in your view, an acceptable substitute for having tested the durability of dampers in a dual environmental and smoke control situation?
I think it's an additional thing. It's not in lieu of. Again, I'm only presuming a product that can get through that number of cycles and be exposed to heat looks slightly different to one that doesn't. So that's the first point. And then again, as covered at length in module 3, I think it is, the RRO module, yes, maintenance was needed anyway, and we know that didn't really occur. So in my mind, it's two separate things, not one or the other.
Yes. Now, Mr. Jones and Mr. Lay both refer to the relevance of the shafts being depressurised when assessing the risk of smoke leaking out of the damper. Now, can we agree that just as a matter of basic physics, if the shafts have negative pressure relative to the lobbies, smoke shouldn't leak into the lobbies?
Correct.
Now, is it your view that a smoke-controlled system designer is entitled to assume when designing the system and specifying the dampers that the shafts will remain depressurised during a fire through correct operation of the fans?
No, that they're trying to make that happen. That's the whole point of your fan selection, all the different things that have to be accommodated into your final fan rating. That's what you're trying to do. So anything you forget to incorporate at the time, it may mean the fan, in the event of a fire, can't cause the necessary negative pressure. Okay?
And would you ever allow for fan failure when you're picking your dampers? Would you ever say to yourself, well, I can't assume that the fans would always start and that there will be negative pressure in the shafts, so I need to make sure that my dampers would be capable of dealing with excessive leakage in the event that the shafts aren't depressurised?
Yeah, understood. So my understanding of, how do I know this? The idea of having, restricted leakage in a damper is that it can. I understand that it's not meant to provide the level of, let's call it, compartmentation only when the fan is on. No, that is not my understanding. I think that's what you're asking.
Yes.
It's meant to be able to provide the compartmentation aspect as a compartmentation device. Okay, does that make sense? So it can't only provide compartmentation if the fan happens to go on too. That's as I understand things.
Yes.
Yeah.
So take the south shaft, for
Yeah.
example.
Yeah.
And we'll see some figures for this in a moment. Assume at low level fan speed
Yeah.
that actually that fan wasn't being very effective,
Yes.
and assume that you got some smoke venting up the south shaft as a result.
Yeah.
I think what you're saying is that you've got to assume in your design and your damper selection that your dampers up and down that south shaft and indeed the north shaft could hold back excessive smoke leakage.
So we have to be careful. About this now. So let's call it a certified damper has let's call it a minimum acceptable leakage. And that's all that's possible. It's not thought about anything beyond that before the Grenfell fire, based on my experience. Does that make sense? So a certified damper, if the fan goes off or is off or something happens, will have a minimum leakage potential only. Okay? We can't stray beyond that.
I understand.
Yeah.
Let's look at your supplemental report, BLARP 25043, and I want to look at page 143. You've extracted here the table of airflow speeds across the north and south shaft dampers, which Mr. Partlow of PSB measured during commissioning. And you've highlighted some of the figures with coloured boxes. So figures in red show a negative figure, which means that the pressure in the shaft was in fact higher than in the lobby. And then you've highlighted some in yellow where there was just simply no pressure differential between the shaft and the lobby. Now, can you just explain the significance of this and why you've included it in your report, in your supplemental report?
Yeah, I thought it was interesting, and it's I don't know what conditions the measurements were taken in, first of all. So and Mr. Lay explained this very clearly yesterday, that this doesn't represent the shaft in its entirety in that moment. It's a number from one lobby at a time, so it can't be seen any other way. And it's showing probably that if the two fans were on at the same time, I don't know if they were, but I'm assuming they were, that potentially the north shaft, is basically pulling on the south shaft. That might be one way of interpreting it.
Yes.
Yeah.
I mean, we know that.
In other words, there isn't, it's not demonstrating a suck up the shaft, basically.
Yes.
Yeah.
We know the two fans were
Sometimes,
rated
yeah.
differently, weren't they?
Yes, we
The
do.
south shaft fan, I think, was extracting 2 cubic metres per second, and the north fan 3.6.
They were meant to be, yes.
Yes, so the north fan was meant to be stronger than
Yes,
the south.
it was meant to be.
Mr. Lay said yesterday in his oral evidence, well, hang on a minute. In fairness to this system, it wasn't really intended to be extracting smoke on low mode from the south shaft. So he's not concerned about these figures. And I think in his written statement, he said, well, actually, what this shows is it might be pushing some air out into the lobby and you get some dispersal, so it could be a positive thing. Now, to what extent would these figures have concerned you on commissioning to get these figures showing that the south shaft wasn't performing in the way the system appears to have been designed to operate?
So there's about 8 points. to that
Sorry, I'm
question.
sorry.
Yeah.
That's probably too much.
There's a lot of points there. I think all I'm prepared to say is I don't know the conditions each number was measured in. So it's really hard for me to speculate. Okay? And and also this is these are cold temperature conditions as well. I mean, I could go on. I've tried to explain that. You know, I don't know that there's no big flourishing conclusion here about this data.
Okay.
Okay.
Is Mr. Lay right, though, according to your understanding, that the system wasn't really intended to extract smoke south when it was on low mode? Is that your understanding of how the system was designed?
Well, apparently the system doesn't extract smoke at all. So,
Sorry.
anyway, I think that's Mr. Lay's opinion. I don't have anything to add to that.
I see.
Yeah.
Okay. Mr. Chairman, I think that's a good moment for our afternoon break.
Yes.
I've almost finished this topic, but I'd
All
like
right,
to...
well, we'll take a break there anyway. We'll stop there. We'll come back at 25 to 4,
Okay.
please.
Thank you.
Unusual restrictions apply. Thank you. Thank you. 25 to 4, please. Would you ask Dr. Lane to come back in, please? Right, Dr. Lane, ready to carry on?
Yep.
Yes, thank you. Yes, Miss Grange.
Yes, thank you. Yes, just finally on dampers, I want to look at PSB's justification for not specifying ES smoke control dampers. And so what we know was that it was just the Gilbert Series 54 damper that was selected. No particular performance standard was specified. It was just that damper selected. And Mr. Marnie's evidence was that smoke-controlled dampers weren't used because, first of all, none were available on the market at the time, and secondly, he said the dimensions and the size simply wouldn't work with the size and position of the shaft at Grenfell Tower. Now, if we can bring up your addenda and errata document, please, at BLARP 25044. At page 3. And in section 1.1.1, you set out your methodology in relation to a search for smoke control dampers and fire and smoke dampers from 2015 that were available on the market in June 2015. So you tell us at 1.1.2 that you carried out a limited and ultimately time-constrained search of dampers available on the market in June 2015. And you tell us at 1.1.11, 2 up from the bottom of the page, from this limited activity, I've found that 2 smoke control dampers and 2 fire and smoke dampers were available in June 2015. And you summarised your criteria for the search of products that you did at paragraph on page 4 of this, over the page at 1.1.19. So the criteria you were looking for was, these are, if the product achieved at least the required fire and smoke performance of ES60, was stated as suitable for use in a concrete and masonry wall, and was available in dimensions that would fit the existing openings of the north and south shafts. Now, in this document, you've emphasised that you carried out a limited search only, in particular focusing on the Loss Prevention and Certification Board Redbrook scheme, although there were other third-party certifiers at the time. Is that correct?
Yes.
And then on paragraph 1.1.3 on this page, further up, you say this, it's not a matter for me to carry out any further work on this subject. I've had no access to project-specific mechanical engineering or construction detailing, and thus make no attempt to conclude on this matter beyond stating there appears to have been in 2015 some suitable products worth considering, and with the relevant performance requirements for the Grenfell Tower primary refurbishment work. Now, the results of your search are then summarised in table 1.1 on page 5 of this document. So there we've got the products that you identified. So 2 smoke control dampers and 2 fire and smoke dampers that were identified and satisfied the criteria that you were looking for. Is that correct?
Yes, that's correct.
And would you have expected a reasonably competent system designer to have searched for and specified one of these dampers, all of which have at least an ES certification?
Yeah, so in my quick search, I found these 4. I looked at area of opening only also, and these are the 4 that I found. And yes, I would expect a reasonably competent person to carry out a more extensive search.
Yes. Now, Mr. Lay has said, and he made clear, in fairness to him, that he hasn't had very long to look at this, which he hasn't, that in his view, at least some of these dampers would potentially stick out too far into the lobby.
Yes.
They would protrude into the lobby. Now, what is your response to that point?
Yeah, so the 2 so I checked the depth last night. The 2 fire and smoke dampers are the same or smaller depth, and the smoke control dampers are deeper than the products installed in Grenfell Tower. Yeah.
Right.
Yeah.
So does that, I mean, he seemed to think that that would have been an impediment to using them because they'd stick out from the wall, the smoke control dampers.
Yeah. But this
Do you agree with that?
So this is exactly why I didn't want to do any retrospective design work on my own. So I found these 4 products, and then I would want to sit down with various people and work out what could be installed appropriately in Grenfell Tower, and I'd go off and find some others as well. So on the surface of it, yes, one of the smoke control dampers particularly would substantially stick out of the wall if it was installed the same way.
And might that preclude its selection?
It very well might in the end, yeah. But that didn't happen at Grenfell Tower.
And how much of a problem would it be to have dampers sticking out into the lobby? Is that not an ideal situation to have? Or have you ever had a situation where you would take the plain line of, say, a damper out to ensure that you've got a better performance specification of it?
Out-of-plane dampers are very common, but I think this isn't really an out-of-plane damper situation. So out-of-plane dampers are very common, and then again, this is pure speculation because I wasn't on the design team for Grenfell Tower. You'd have to think then about if that could be incorporated into the lobby shape somehow without removing, say, comfort and access. But just really I'm just pure speculation now.
Yes.
But an out-of-plane damper is commonly used in buildings. I'm not implying to the extent this one might have been in Grenfell Tower.
Right.
Okay.
But I think what you're saying is at least 2 of these wouldn't have been significantly out of plane.
The fire and smoke dampers, which would have a substantially better performance than the smoke ventilator, are of a similar depth. Okay, and that's all I've got to say. This was a quick check looking at some products, and this is a list I produced.
And when you say they are of a similar depth, do you mean they're of a similar depth to the Gilbert's ones that were installed at Grenfell Tower?
Exactly, yes. The smoke control dampers are deeper than the installation at Grenfell Tower.
Yeah. Now, in the event that a designer couldn't source an appropriately certified damper, would you expect a reasonably competent designer to record and communicate any such restrictions or limitations in the context of this fire safety equipment?
Yes.
And in the event that Mr. Marnie was unable to identify a suitable damper to perform the required duties at Grenfell Tower, what would you have expected a reasonably competent smoke ventilation system designer to have done?
I think we're back to the same themes again. So that there was a performance standard written down in the first place. So the reasonably competent, what did you say, smoke ventilation system designers, is that what you said, weren't operating on their own?
Yes.
Yes. And I've no evidence that there was an attempt to source in the first place, which is more important in my mind. But if there had been an attempt to source one and there was problems with its installation and impacting the lobby, I would expect that to be a design team consideration and some kind of final conclusion reached. I don't think the smoke ventilation system designer would contractually be allowed to make that decision on their own on a job where it was interfering with a public area.
Okay.
Okay, I'm not really prepared to go any further than that.
So I think what you're saying is that it would need other members of the design team to be content with the situation if they couldn't put in the dampers that they felt were necessary.
So either they were prepared to have some kind of obstruction in the lobby, unlikely, or we're back to then I would, if the smoke control dampers, there again we're back to the same situation where that impacts the compartmentation, not just the smoke ventilation system, and there's a performance issue around the functional requirements. I think that's a very difficult thing to do on your own, as a smoke ventilation system designer, I think was the phrase you used. Okay.
Now, just briefly, thinking about other system components, the fans, in your Module 3 report for the transcript, this is at page 15, paragraph 10, 810, BLARP 2, 5036. You say that the extract fans for the system were not correctly specified, and you say that the system's extract fans should have been rated to a temperature of 1,000 degrees C when tested and classified in accordance with the relevant standards. Now, the depressurization systems that are referred to in the standards you quote are all extracting directly from a fire zone. Does that change your view? Is it relevant that the British standards you refer to are talking about extracting directly from a fire zone? Does that mean that the fan perhaps didn't need to be rated so highly at Grenfell Tower in terms of temperature?
Okay, so so I've updated the temperature expectation for a fan in an unsprinklered building since then. What did you say? So because the fan isn't extracting smoke
Directly
from the fire,
does that affect the extent of performance of the fan that's required?
It could be a consideration, yes.
The guidance in the SCA guidance at section 8.2.6 in the 2012 SCA guide on page 37 states that a typical fan specification for a mechanical extract smoke system will be for 300 degrees C for 60 minutes.
Yeah.
Do you consider that to be an adequate standard?
That's the standard typically specified in a sprinklered building.
I see. So you're saying if it's not a sprinklered building, you potentially have to allow for higher temperatures.
Typically, you raise the temperature standard for your fan.
I see.
Yeah.
Can we look at Mr. Lay's report briefly on this? It's at LAY 701 at page 216. And at page 736 to 738, he says this. He says, fans are often specified with a temperature rating below the fire temperatures expected in compartment fires, which can exceed 1,000 degrees C. This is in part a practical measure, as fans that could tolerate extreme temperatures are not practically available for the general building market. Now, just pausing there, is that your understanding as well?
In an unsprinklered building, yes, the temperatures can be extremely high. And no, that's, yeah, yes, I agree with that concept, yeah.
Yeah, but I think the point he's making is that fans that could tolerate extreme temperatures are not practically available.
Yes, I understand that. I understand the rating of fans that one can buy, yes.
Yeah, you agree with that?
I do, yes.
He says also the movement of air over fans will typically ensure that they're exposed to a lower temperature than a compartment fire, and where fans are remote from the fire compartment, significant cooling of the smoke will take place before it reaches the fan. Again, do you agree with that that's a relevant consideration when you're specifying your fan temperature?
Yes, that is a good consideration when one is thinking about a fan. Yeah.
And then he says, at the next paragraph, the SCA guide includes data from the BRE study, and then he gives the name of the study, which provides information on expected fire sizes in unsprinkled dwellings and characteristics of flow, leaving the fire flat by the entrance door, and he's included this information. And if we go over the page, he says there, the fans were in line with the expected standards set out in the SCA guide. Sorry, I just want to see if there was paragraph 7.38 back on the previous page. Yeah. Sorry, if we go back up. So he's got a table of data from that study. Thank you. And he says, from the data in figure 215, it can be established that with an extraction rate of over 5 cubic metres per second, the temperature of smoke at the door of 690 degrees C is reduced down to below 300 C when it's mixed with ambient air entering from the inlet pathway. This has been confirmed in modelling, such as that used by Colt for the type of approval of the Colt shaft systems. Whilst care should be taken in applying results from one system to another, the significant reduction in smoke temperature by the the time smoke reaches the fan is well established, and the 300 degrees C recommended by the SCA guide for relevant parts of a smoke control system is expected to be adequate.
Yeah.
Now, again, do you agree that based on some of the information, including from the COLT modelling that's been done, the SCA guide's recommendation of the 300 degrees C is adequate?
Is adequate. I think we've been through the COLT modelling. It's for a specific type of lobby and fire size, and ultimately I don't agree that in an unsprinklered building a fan at a rating of 300 degrees Celsius can automatically be considered adequate. No.
Right. And what added in the system?
So we would typically recommend something at 600 degrees C, and they are purchasable and practicable on the market.
Okay, thank you. Just before I come to your overall concerns about the design of the system, because you've helpfully summarised those in your supplemental report, and I'll quickly take you to that. Do you agree that these systems can be quite temperamental, these smoke control systems, and difficult to get to work in practice? Is that something that's recognised within the industry, known about? Yeah. Is that your experience?
Yeah, I don't think they're temperamental, but I think that they're, all the different parameters that we've discussed today, and in Mr. Lay's report and in my report and in all the evidence, I think they're very complicated systems, sometimes with competing parameters. They tend to be very delicately designed, to put it that way, and so they can be susceptible to reacting to small changes in states. And my experience, particularly when I've been in the unfortunate position of trying to commission one, and I think Ms. Menzies raised this as well, it can be very difficult for quite some period of time until you get all the, I call it, balancing right. Okay? So there, you could call it a highly engineered system that's susceptible to small changes in state. Yes, that is my experience.
Thank you.
Yeah.
If we go to your supplemental...
Sorry, before we do go somewhere else, could I just go back to paragraph 738? I just want to check on one thing.
Yeah.
What Mr. Lay is saying in paragraph 738 is that you can expect to get some mixing with ambient air as the smoke leaves the flat and enters the inlet pathway. So the temperature, he says, will have come down fairly significantly by that point. You've then got the smoke rising up the shaft and mixing with other air at that point, which I think he would say gives you a figure of well below 300 degrees centigrade by the time it reaches the extractor fan.
Yeah.
Do you disagree with that?
Well, so it depends where the fire is, the size of the fire, and how close it is to the fan.
Well, you're assuming that there's a single fire in a single flat, I think. For this
up at level 23.
All right, up at level 23. And that the smoke comes out of the door for whatever reason.
For whatever reason, there's some temperature. Again, I don't like speculating. I don't like speculating like this. So I understand on a lower floor. So the phenomena as described, I understand and agree with it. It's not wrong.
Right.
Okay. But as a designer, you've to make a choice about how fine you're going to go in terms of a reasonable scenario. And all I've got to say is that we choose, in an unsprinklered building, with this type of system and residential, we try not to go recommend a 300 degree C fan. Yes, other people do.
Well, my question...
I'm sure Mr. Lay can help there. Yeah.
Well, my next question was going to be, in your view, is it unreasonable to choose a 300 degree rated fan?
I think where you have considered it and explained it and you've satisfied yourself that the range of scenarios relevant to your building and you can justify it, I would rarely have a problem with that.
Right.
Okay?
So I think,
But I don't see any of that. You know, it's always back to the same thing in Grenfell. I'm not in that position to tell you that that's what happened.
well, I understand what you say about not having the workings, so to speak,
Yeah, yeah.
but I don't understand you to be saying that no reasonable designer could have opted for a 300-degree rated fan.
No reasonable designer. I'm sure a designer could reasonably come to their conclusion that a 300-degree C fan was appropriate for Grenfell Tower. Yeah.
That's what I just wanted to be clear on.
If they can satisfy themselves that 738 is applicable in all reasonable scenarios.
All right.
Is that
very
okay?
helpful. Yes, that's helpful. Thank you very much.
Yes, thank you. Thank you, Mr Chairman. Let's go then to your overall conclusions, just briefly look at those. BLARP 25043 at page 89.
What subject are we on again? Sorry, got a big... where are
This
we
is
now?
where you've set out your overall conclusions about the design of
Oh,
the
yeah.
system.
Okay. Yeah.
And at 4.6.7, you say, these documents therefore contain the information needed to avoid the serious issues with PSB's approach to the performance standard they expressly designed into their system for Grenfell Tower. And I think you're talking about various, the SCA guides, BS 9991, etc. And then you say these are failure to consider performance objectives and the associated relevant leakage paths in sizing the components relied upon in the system design, failure to comply with the performance recommendations of individual components such as lobby dampers, failure to comply with the functional requirements needed from the system as a protected shaft in an unsprinkled high-rise residential building with a stay-put strategy, failure to consider the hazard posed by extended travel distance in the lobby and methods to mitigate it in the absence of mitigation from the system design, failure to consider the performance of other passive and active measures, e.g. fire doors, self-closers and dampers when considering the hazard of smoke leakage to lobbies, and failure to consider all the above in the context of interlinking of the functional requirements B1, B3 and B5 in an unsprinkled high-rise residential building. Now, does that remain an accurate summary of your views about the flaws in the design process for Grenfell Tower?
Yes. Yeah.
Now, briefly, commissioning and approval. Now, in your Module 3 report for the transcript, this was at 10.13.6. You said at page 25, BLARP 25036, that the commissioning process, even in the context of the limited performance criteria set by PSB, did not demonstrate compliance with Regulation 7 of the Building Regulations 2010. Now, having heard the evidence of those involved with the commissioning and now also Mr. Lay's views on the commissioning yesterday, does it remain your view that the commissioning process did demonstrate compliance with the building regulations?
Yes, it does.
And in terms of Mr. Partlow's evidence about the process of commissioning, to what extent have the concerns you raise in your report been addressed by his further evidence about the steps he took to commission the system, even though all those steps weren't documented?
So, what did you say? How much have they been allayed? Is that what the question is?
I mean, what I'm really asking is it acceptable when you're commissioning a system not to document all the steps in the commissioning process?
There are two questions here. I'm sorry to interrupt you, but one is whether it's acceptable not to document the steps.
Yes.
Okay.
The other is, if the panel were satisfied that what Mr. Partlow said was correct, in other words, of the truth of what he'd said, how does that affect the witnesses?
I'm happy to put it in that way, exactly.
Okay.
So, first of all, is it acceptable not to document all the steps that were taken as part of the commissioning process?
So the documentation is not just about the steps, it's about the data. So, you know, we've been obsessing about the airflow measurements and, you know, moving the lines up and down. The whole point of documenting and recording the final state data is to be able to have these conversations knowing that's what the final state is, okay? So that's the one thing. I listened to everything very carefully, and I've reread Mr. Partlow's extensive evidence. There's a few specific things I still don't get as such. So I don't understand how, when I look at the ladder logic behind the control panel, I don't understand how there's a different fan speed in high and low at every floor, for example. There's a big long list of things. There's a list of things that I still don't understand. And I didn't get comfort at the end that the dampers had been visually inspected, because remember, they're open in environmental mode, so the visual inspection of the dampers and the very final airflow rates when the system and all the cause and effect testing was finished, I just can't see that I have that still. So I am uneasy about changing my mind about the commissioning based on my own experience also of commissioning and witnessing others commissioning.
Yes.
Okay.
And to pick up the point about the dampers, in his oral evidence, Mr. Partlow explained that when checking the dampers, he would use his laptop.
That's correct.
To monitor whether the dampers on any other floors had opened or whether they were closed.
Yeah.
Is what you're saying is it would be very important for there also to be a visual check.
Yeah. Because that's about let's say that's about the signalling coming from the control system, and that actually, in all the scenarios we've run, you know, that is robust, okay? But the signal and then what the item at the end of the signal does are two different things, and that's why it's so important. Yes, the signals have to be accurate first, and then it is that product, whatever it is, responding appropriately to the signal. So doing nothing, closing, opening. And when you've done this a few times, and Mr. Partlow was very clear on this, you see that it's not so simple to get all of those things to work until the very end. And that's why recording that end state is so important to prove that all the different products could do the right thing at the right time, okay? And I just can't find that surety from my perspective.
And does that mean that commissioning a system like this is quite a labour-intensive process? You might need lots of people assisting with the commissioning to ensure that you've got visual inspections of other dampers when you're testing on different floors.
Not lots of people, but more than one. I think it was 2 people, wasn't it? I think you would definitely need more than one person.
Right.
I suppose you're going to ask me now, how many people would I bring? I haven't thought about that. So it's not lots of people. We don't need to kind of over egg the situation.
Yes, I see. So having considered Mr. Partlow's evidence, do you consider that overall, and setting aside your concerns about recording results, do you think the process taken was sufficient to demonstrate that the system was performing as intended?
I don't think so, no.
Again, can I just ask you,
Yeah.
is that because you don't accept what Mr. Partlow says in its entirety, or?
No, that's not, no, because I think Mr. Partlow gave very thorough evidence. So it's not that I've decided it should be dismissed. It's a whole series of things. Actually, I should have written this down. So it's the issue of not visually inspecting the dampers. We still don't know what the fan speeds were in high and low. And he explained in his oral evidence that he had different settings on every floor. I just don't understand that at all, because there's one high signal, one low signal in the control panel. So I don't know how he said he had a different number per floor. And just a few things he said didn't reassure me, okay? But it might be more robust if I was to set that out properly rather than try and answer it off the hoof here. I do think that he was very expansive and helpful in what he said here.
I mean, I raised the question because, and I understand how you forming a view which depends to some extent on your assessment of various bits of the evidence, including what Mr. Barclay says, and including the data that you've got, or in some cases don't have.
Yeah.
We may or may not find it necessary to make decisions about some of the detail.
Okay.
But if we do need to grapple with it, I think we need to understand why you don't think some of the evidence is reliable.
Yeah. So it seems to me that everything happened very quickly at the end, and I know what that is like from my own experience. I think that I know myself that when members of my team or other teams want to do the damper checks electronically rather than physically, I always say no, because it's sod's law. You will miss one, or there's something wrong. I don't understand the fan speeds. I don't understand I don't understand this judgment on the door and the pressure switch. And I suppose in my mind there was a level of judgment for each system which, taken all together, demonstrates some lack of rigour, I think is probably the best way to say. And in a complex system like this, that would make me feel less confident in it than more confident that what had been done on site was to the right standard. And I am drawing in my own experiences in the past of similar activities.
Right. Thank you.
Is that all right? Yeah.
Cold smoke testing now. In her supplementary report on smoke control, Ms Menzies says, and for the transcript, this is paragraph 291, BMER 607 at 68. She says, in my experience, systems are generally demonstrated on site using a cold smoke test to illustrate the directional flow of smoke, the speed of dispersal and level of visibility. Whilst this will not fully replicate an actual fire situation, it will be indicative. As far as I can ascertain, this was not suggested or undertaken. And when she gave oral evidence, she was clear that a cold smoke test was an important part of commissioning and accepting the system by building control. Now, do you agree with what Ms Menzies says in that respect?
Yes, I do.
Do you agree that in the absence of a cold smoke test, it would not be possible to know whether the system worked, including for the different door opening conditions which were foreseeable? So Ms Menzies said that the doing a cold smoke test would assist in working out what would happen with the system when you did have more door opening conditions.
I'm happy to agree with the word assist. It's not it's not the only thing that should be done, but it will assist along with all the other data measurements from the devices.
Mr Lay said in his evidence yesterday that, well, that might have been done 15 or 20 years ago before this type of system became much more accepted. He said he had done a cold smoke test once with Miss Menzies, but it was not a representative test. It didn't involve hot smoke, and therefore he wouldn't have seen it as a test which needed to be done on this system. Do you agree with that?
No, I don't. And we have, in the end, we actually bought our own smoke machine so we could arrive on site and use it, and I find it to be most helpful indeed.
So whenever you're commissioning a system like this, would you always do a cold smoke test?
We always try to, because we always try to, because depending on what the position you're in,
and is it
it's a good way of exposing what you might not have worked out yet, or you might not know about the system.
But if I had to push you on this and say, would it fall below the standards of a reasonably competent commissioning person not to do a cold smoke test? What would you say?
Well, what I would say is, it's a really easy thing to do. It's not expensive, and I can't imagine why you wouldn't do one, especially when it comes to the approving authorities and a system like this. Quite frankly, they absolutely love to see it working, and it gives people reassurance. That's my experience. I think it would be pretty unfair for me to say that, it's this thing, it's the same with the documentation, only for the cold smoke test, I wouldn't have any problem with the system. But I think, it's an easy thing to do particularly in an existing building and with the system with all these different parameters. I think that's about the fairest I can be.
So you wouldn't want to venture on what other people do? Because I ask because it sounds like it's not Mr. Lay's experience that this is done as a matter of routine.
Yeah, well, he's never come commissioning with me.
It is, exactly. In your case, it is routine.
Yeah.
But what about the rest of the world?
The world.
Are you able to say anything about what they do?
Mr. Chairman, we do have Miss Menzies' evidence.
Yes.
Well,
She
I'm
says,
just-
in my experience, they are generally demonstrated on site.
Yeah, well, that's Miss Menzies' evidence. I'm now inviting
So
Elaine to give us her evidence.
I think that there's a lot of, there are people out there who love a nice cold smoke test, and I think it's reasonably common. I can't comment on Mr. Lay's experiences, but certainly for projects I do with Arup and with other consultants, because we do both, I think my experience is more common than not that you would do a cold smoke test, particularly when you have I would say that, a really interested approving authority and they want to know exactly what's going on. Okay.
All right, thank you.
Is that okay?
Yeah. Well,
Can I just follow up on that?
Yeah.
In the situation we had at Grenfell Tower,
Yeah.
where we know we had a system which didn't have detailed design documentation
Yes.
behind it,
Yeah.
didn't have performance objectives specified, etc.
Yeah.
Would that mean that not doing a cold smoke test in that situation would fall below the standards reasonably to be expected because you hadn't done the calculations in the first place?
Yeah, I fully agree with Miss Menzies on this. And it should be, it not only should it have been offered, it should have been asked for by building control.
Thank you. The night of the fire now, I just have some brief questions on that. Just to be clear, this is going to be primarily a factual matter for the panel and the chairman to decide, in fact, what happened on the night. Did the system work? Did it not? What is the evidence? And most of that is factual evidence. And just to be clear, you're in the same position as Mr. Lay, aren't you? You're not a forensic fire investigator, are you?
Absolutely not. And I haven't carried out a forensic fire investigation in my Section 12 and Section 13 of my report. That's not its purpose. Yeah.
So is it fair to say that all you can do, again, like Mr. Lay, is draw certain factual matters to the attention of the panel and provide a non-expert opinion about what that might tell the panel about what occurred on the night using your experience of these systems?
Correct. Yeah.
Yeah. Now, I've just got a few questions on this. The level 11 north dampers and the potential breach of compartmentation involved with that. In your supplemental report, this is at page 17 for the transcript, paragraph 1.4.53,
Yeah.
you say that you and Mr. Lay disagree about whether there was a likely breach of compartmentation by the north shaft level 11 dampers on the night of the fire. Now, can we just go to your storyboard in your Module 3 report? It's at BLARP 25038, page 29, and it's storyboard 1312.
Yeah.
So this is where you analyse the performance of the north shaft as a protected shaft.
Yeah.
And the diagram is divided into early, middle and late stages of the fire.
Yes.
And if we look at the text box pointing at L11 in each diagram, pointing at level 11, you've got, for each diagram, you've got a label identified as box number 3, which says likely that level 11 north shaft dampers were open for the duration of the fire. Do you see that?
Yes.
And in respect to the early stage only, you say below that in box 4 on the left-hand side, spread of heat and smoke possible between level 4 and level 11 lobbies due to open north shaft dampers. Now, can you just briefly summarise what evidence you relied on when concluding that it was likely that the level 11 north shaft dampers were open for the duration of the fire?
The BRE forensic analysis of the dampers.
So we looked at that with Mr. Lay yesterday. You're saying you relied on the BRE's post-fire investigation report, is that right?
Yes.
And the fact that they indicated that there was some visual evidence of a cleaner line along the blades of the north shaft dampers, which might indicate... I'll start again.
Yeah.
It indicated that for the south shaft dampers on level 11, there was a line indicating a difference between the smoke at the blades.
Yeah.
And there was an absence of that for the north shaft dampers, which were more uniformly coated in smoke and soot. Is that right?
Yeah, so in my mind, one shows movement and the other doesn't. That's how I saw it in my mind. And I accepted what BRE observed.
Let's just look at that. It's at MET 3039807, page 112. And it's paragraph, they deal with 153 and 154, what they found on the low-level dampers. The metal surface on the edge of the blade tips, where the blades normally contact each other, was noticeably cleaner and had less smoke and soot residue than the rest of the blade surface. And then if we go down to paragraph 155, they contrast that with the high-level dampers. It says inspection of the high-level dampers showed that the contact points on the damper blade tips were uniformly coated in smoke and soot. Therefore, unlike the low-level dampers, there was no visual evidence for the high-level dampers being closed during part of the fire. Do you see that there?
Yes, yeah.
So is it that part of the BRE report that you were relying on when concluding that it was likely that the north shaft dampers were open during the fire?
So did you say I concluded? Yeah.
So you said in your text
Yes,
box that it was likely they were open throughout the fire.
Likely, yeah, that's correct. And that's based on the BRE text you've shown here and similar text for all the other dampers.
Now, I know this isn't your text, and I understand, I think, the principle that if the 11th floor north dampers were uniformly coated with soot, that's evidence that they were open for a considerable period of time. Does it tell you anything in your expert view about when they opened,
So
or for how long they were open?
I'm not an expert in soot deposition on any level, and I'm not a forensic fire engineer. I hope, I can't tell timing. I hope I made that very clear, that it's not possible for me to confirm a time anything happened. I actually said that at the very start of all of this analysis.
Well, I asked the question because your diagram
Yes.
had a label saying open throughout the fire.
So So it says likely open throughout the fire.
Well, it was the throughout the fire that I wanted your help.
That was based on the BRE text only and no other.
Right.
No other. I didn't draw anything else in.
No. Right. Thank you.
I mean, both you and Mr. Lay then go on to analyse some of the factual evidence about the movements of residents on level 11. I'm not going to take you through all of that now. We've got it set out in detail in Mr. Lay's report, in your report, and we also now have Professor Peirce's report, who's also considered the timings of movement. But I think that the point he makes is there may well have been a flat door open from quite early in the fire due to movements of the Jafari family. And the point you make is that when you look at the timings, I think you're saying that doesn't necessarily follow, given the timings, and that there may have been another source of smoke on level 11. Is that a fair summary of the difference between you?
Difference between myself, I haven't read Mr. Purser's report. Are you talking about Mr. Lay's
I was talking about
report?
Mr. Lay and you.
Okay, so we need to be very careful. So I looked at level 11 and level 18 to try and see if there was information that could allow me to say with some surety or not that the events that caused the dampers to open at level 11 happened before level 18. The level 18 damper was the end state. Didn't want to assume one thing or the other. So that's why I did that analysis. The second thing then, I was trying to see if you could definitively state it was damper leakage or flat entrance doors being open, and at level 11 and level 18 also, because then I was going on to try and work out when this extreme event at that lobby may have occurred to trigger the scenario that Rena said causes the dampers to operate in an unexpected way. That's what I was trying to do.
Thank you, that's helpful.
Yeah, and it can't be taken out of that context. So I was trying to work out when extreme fire was possible, and thus the Rena triggering of the dampers, and then if level 11 was likely to have occurred before level 18. And everywhere I have likely and options, because I don't find that it's possible as myself to say one thing definitely happened. And I hope I haven't given that impression at all.
That's helpful.
Yeah.
Just help us with this. If the panel were to find that there was a damper open at level 11 throughout the fire, level 11 north shaft throughout the fire, if that was the conclusion.
Yes.
Just what is your opinion about what the effect would be on the operation of the system? Because Mr. Lay's evidence is essentially, well, that would make no difference because there's negative pressure in the shaft and you might get a little bit of turbulence of smoke, but no more. Now, do you agree with that if there's a damper open higher than the floor in which it's operating on, so suppose the smoke control system's operating at level 4, where the fire is, but you've got a rogue damper that's open at level 11, say, do you say that would have had an effect on the performance of the system?
Well, my understanding of that is, so if this happened, when the fire started on level 4, and if the damper was open at level 11, when the damper is opened appropriately at level 4, the fan from the get-go is extracting off two open floors. Mm-hmm. And in the event that hadn't been incorporated in the design, and it's highly likely that it wasn't, it does impact the resulting airflow potential at level 4.
Why does it have an impact if the shaft is depressurised because of the operation of the fan?
Are you talking about, I think you might be talking about leakage upstairs now. It's another leakage path. It's another...
well, to put it in layman's terms, the fan at the head of the shaft is drawing from two places, not one.
No, exactly. I mean, I was going to say it's split in two, but 1,000 people were writing in explaining that it's not that linear, and I understand that. But in really, really, really crude terms, that's what you're doing if that damper was open.
Okay.
Yeah.
Thank you. Now, another topic that you've dealt with in response to Mr. Lay's report is he has highlighted some firefighter evidence, including evidence from firefighter Moore, who gave evidence at phase 1 that suggests that smoke may have been venting from the south extract point at about 3:30 a.m. on the night of the fire. That's Mr. Lay's in Mr. Lay's report. And you've responded to that in your supplemental report. And in your report, you make reference to your own site visit observations and you comment on the evidence of firefighter Moore.
Yeah.
And you say this, you say, I had the benefit of visiting the site post-fire, unlike firefighter Moore. I was able to observe the south elevation from firefighter Moore's location under the external concrete mezzanine walkway. In my opinion, the sole photograph that firefighter Moore was shown, this was during his evidence, gave insufficient information for him to confirm which vent of the 5 vents potentially was visible to him on the night that he was able to observe. I'm in no way criticising Firefighter Moore, and I note the proximity of the external walkway to Grenfell Tower and the relatively confined space between it and the tower, into which large and small debris, burning debris and human remains fell throughout the night. And you produced a photograph in your report. If we could go to that in your supplemental report, BLARP 25043 at page 187. Now, that's the photograph that you had in your report. So can you explain what this photograph shows?
It shows the canopy and the vents underneath the canopy.
And are those the vents that went to the south shaft
No.
smoke control system?
No.
So the vents that are immediately above the Grenfell Tower label,
Yes.
those aren't the smoke control vents,
No,
is
they're
that
not,
right?
no.
They're at level 2, they're higher up, is that
They're
right?
much higher up, yeah.
Let's go to INQ 30151558. This is a screenshot showing a database of photographs from Getty Images. Perhaps we could blow them up. And it was made available to the inquiry by the Metropolitan Police Service.
Yeah.
And here we can see some different photographs.
Yeah.
There's 3 there of the entranceway
Yes.
to Grenfell Tower. Now, does either of those photographs, the ones that are further out, show the level 2
Yeah.
vent?
No, so the one where you can see, say, three panes of glass above the green canopy,
Yes, the one at the
Vent.
bottom.
yeah, the vents are not there.
Right.
The level 2 vents, excuse me. Obviously, the vent underneath the canopy can be seen.
Right. And was there a particular reason why you chose the photograph that you used for figure 8.1, which was a much closer image of the tower? Was there a particular reason why you chose that photograph?
No.
Now, with reference to these photos, is it right that you think that Firefighter Moore could have been mistaken in the evidence he gave about seeing smoke coming out of the level 2 smoke control vents?
So Firefighter Moore saw what Firefighter Moore saw, but he was asked a question about a specific vent, as I've said in my report. I decided to go down and try and see what I could see in under the walkway, at the edge of the walkway, or further out past the walkway. And unless you step out into fresh air, you can't see the smoke vents up at that height. That's all I observed.
I see. So if
Yeah.
you're standing underneath...
You have to go right out. You have to step out and stand there. And that made me think that when he was asked, the question he was asked completely out of context, it was very difficult for him to understand that there was another vent, the ones shown in these photos here. And at different times in the night, there was smoke in the lobby. And there was also smoke from other sources in that area. And I consider all of that sufficiently, there's multiple different options in what I've just said there. I couldn't say that he saw one thing, the one thing only.
Okay.
And it's not meant to mean anything more than that. And it's absolutely not a criticism of Firefighter Moore in any shape or form.
Okay. Thank you. Mr. Chairman, I've come to the end of my pre-prepared questions.
Right.
Perhaps
Well, we
could
better have the usual break then, hadn't we?
the usual break.
Lane, I don't need to explain to you why we have a break at this stage. 10 minutes ought to be enough, oughtn't it? 10 minutes?
Yes, I think it should.
Well, if it's too long, you can send the usher to come and collect us as soon as you're ready. We'll have a break for 10 minutes unless we're called back in. 20 to 5, please. Thank you. Thank you very much. 20 to 5 unless you call us back soon. Right, thank you. Thank you. Would you ask Dr. Lane to come back in, please? Thank you. All right. Well, let's see if there are any more questions, shall we? Yes, Ms. Grange?
There are no further questions
No
for
further
Dr. Lane. I just want to thank her very much for all the assistance that she's given us on this topic. So thank you very much.
Yeah.
Well, quite right. And I must add my thanks and the thanks of the other members of the panel
Yeah.
to you for all the work you've done on this
Yeah.
inquiry. It's been enormous. And thank you again for coming back, I think, for the third time now, isn't it?
It's the 10th time.
No, not giving, you haven't given evidence for 10 times. It may feel like it, but you've certainly given evidence on 3 occasions.
Yeah,
And we are
yeah.
very grateful to you for all
It's the
this.
10th day. Yeah.
The 10th day.
Yes, my 10th day answering questions here.
Right. Well, I
Yeah.
hope the experience hasn't been...
It's been
too
horrendous,
unpleasant.
but worthwhile. And as Mr. Lay said yesterday, it's been an honour, of course. So,
Well,
yeah.
thank you. It's right that we said thank you. We are, as I say, very grateful.
Yeah, thank you.
And now you're free to go.
Yeah, thank you.
Thank you very much. Thank you, Ms. Grange. Well, that's it for the day. I should repeat my thanks of yesterday to those who are sitting here keeping us going, and also to those out in the back room who are keeping us going.
Yes.
But we finish there and we resume with a different witness at 10 o'clock tomorrow.
Yes. Thank you.
Good. Thank you very much. 10 o'clock tomorrow. Thank you.